Okay, welcome, to your first video lesson. Big Daddy Waz here to guide you through some Chapter 6, what we're going to call Unit 8. We are going to be looking at, throughout this entire unit, systems of equations. So let's jump right into it. Now, as you go through this video lesson, again, the whole purpose of this is for you to follow along with your note packet. So hopefully right now, check to make sure you have your packet with you to take good notes. If not, you may need your notebook there, okay? As we follow along, if you need to pause at any point, here's the good thing. Big Daddy's not with you live right here, okay? You're listening to him, so make sure you pause when you need to pause. Take good notes. Follow along if you get stuck. Good thing about this is you can stop and rewind and go back over any section of the video you need. Okay, so we're going to jump right into it. Today we're talking about systems of equations, and we're going to solve them through graphing. All right, holy strawberries there, a little Rolling Stones Start Me Up. Hey, got to get started on this here math. So here we go, our learning target for today. Here's what we're going to talk about. Okay, your goal is hopefully by the end of this video lesson and the end of class time, the next time we meet, is you will be able to solve a system of equations through graphing and be able to find solutions from the graph of a system of equation. So let's get started right away. All right, so first of all, what is a system of equations? Well, a system of equations, folks, is really a set of two or more equations. And specifically within this chapter, we're really going to look at a set of linear equations, so equations of lines. Now, equations of lines, we talked about last chapter of looking at y equals mx plus b, slope-intercept form, point-slope form. Really, we're looking at functions that have relationships between x and y. So we're looking at two equations here. So notice how I have 2 instead of 1, and both equations contain x and y. So there are 2 or more equations with the same variables. So we have 2 equations for x and y. So that's a system. Now, what our goal for this chapter is to be able to solve these systems of equations. To do that, what we are going to do is try and figure out what is a value of x and a value of y that's going to make both equations true. So remember when we solved equations before, when we solved the equations, the whole point of an equal sign is that there's a number that I can plug in for x and plug in for y such that the left side is going to equal the right side. So I would want a number like over here to represent 7. So we get 7 is 7. That would be considered a solution to an equation. Okay? So for example, notice here I have x and y. So I want, in this case, a value of x and a value of y. Well, really that's going to give us a point. So let's say I plug in a point of, let's say, 1, 3. Okay? Now I'm just making this point up. This has nothing to do, or this point really has nothing to do with anything. But to find this, if this point is a solution, what I'm going to do is take this point and plug it into each equation. Okay? So for example, if I take this point of 1, 3 and I plug it in here. So this value of 1, remember this represents x and this represents y. Okay? So if I take the value of 1 and plug it in for x, and take the value of 3 and plug it in for y, I'm going to get this. 1 plus 2 times 3 equals 7. And if this point is a solution, if this x and y combination is a solution, I'll find that this equation is true. Now if I check, okay, 2 times 3, in order of operations, multiply those first. 2 times 3 is 6. If I add 1, so let's see, 1 plus 6, does that give me 7? And that works. Okay, so that would mean this point of 1, 3 is a solution to this first equation. Now that we have, instead of just one equation, since we have a system of equations, in order for this solution to be true, we need to make sure that it fits and works for both equations. So I'm going to do the same thing. I'm going to take this point of 1, 3. I'm going to plug 1 in for x and 3 in for y. And let's see if this works. So what I have here is my point of 1, 3. So what I'm going to do is plug this in for x and plug it in for y. So I have 3 times 1 minus 2 times 3, and my goal is to see, does that equal 5? Okay, so 3 times 1 is 3, 2 times 3 is 6. Is 3 minus 6 going to equal 5? And you'll see in this case it does not. Okay, so although 1, 3 worked for the first equation, it does not work for the second. So in order for something to be a solution, the x and y values must satisfy each equation. Key thing here is satisfy each equation. Okay. Now, what our goal for today is we are going to look at how do we solve these through graphing. So we're going to have to kind of remember back to last chapter and how we graph linear equations in order for us to find these solutions. All right, so this is going to make use of a lot of things we talked about last chapter. So we really need to think about how we actually graph, because the goal again today is to be able to graph. So you're going to be getting a system of linear equations, so a system of lines, okay, in which we have to graph. Now, these are steps. These are on your note packet, so follow along. The first thing we need to do is make sure we're going to write both equations in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, okay, where b, if I were to draw a line up here, b represents that point where the line crosses the y-axis, known as the y-intercept. And m, the slope, represents the rise versus the run of that line. Okay, so it's going to be the easiest if we figure out what is this line and slope-intercept form for both of them. So you might be getting equations written in standard form, maybe point-slope form. Our goal first, get them in slope-intercept form. Then what you're going to do is really by graphing the point of intersection. So we're going to graph two lines. Where those lines intersect, that is going to represent a solution. So we want to figure out what is that point. Okay, that point, again, when we find a point, you're going to get an x and a y. Okay, so our goal is, does that x and y represent a solution? Is this going to solve both equations? Then what we're going to do is take each x and y, plug them into both equations to check to see if it works. And if they do, then we know that our solution works, and we're going to write our solution again in xy form. Okay, so the key thing here is really step 2 is the biggest part. We're going to graph our lines. That point of intersection is going to represent our solution. All right, so let's try a few examples. Okay, so here's our first example. What we have are two lines. So I have y equals 2/3 x plus 1, and then y equals 3. So remember when I graph these, the first thing I'm going to start with, let's start with the first equation, y equals 2/3 x plus 1. First thing I'm going to start with is my y-intercept. So my y-intercept of plus 1 means I'm going to go up to my y-axis at a value of 1 and put my first point there. Then I'm going to plot my slope. So my slope is 2/3. So my slope m, which is 2/3, that represents again the rise over the run. Okay, so that means my rise is going to be 2, 1, 2, and my run of 1, 2, 3. So that's going to put my second point right here. Okay, and once I have my 2 points, then I can draw a line that goes through those points. Okay, so that's the first line. Second thing, okay, good. I'm going to look at this one. Is this in slope-intercept form? Yes, it is. Now you look at this one. Okay, where's the x? Why is the x missing? Why do we just have y equals 3? So remember, y equals 3. There's no x value. That only occurs, there's no x, because our slope is 0. So really this says y equals 0x plus 3. How do I know that? Because anything times 0 would drop out. So there's no x because your slope is 0. But I'm going to graph this the same way. I'm going to take here the plus 3. Start with my y-intercept. Plus 3 would be right there on my y-axis. Then I need to plot a slope of 0. Well, slope of 0, you can think of this as 0 over 1. So what does that mean? Well, that means my rise is 0, my run is 1. So as I go from this point, I'm going to go up 0. So I'm not going to move up or down. I'm going to stay there, but I'm going to move right 1. Okay, so I'm just going to give me another point there. Once I have my 2 points, then I can plot my line through there. So my red line, this would be the y equals 3. Okay, so that was my red line, and the first one was my blue line. Okay, so now, looking at this, I can see from this graph that the 2 lines intersect at this point right here. So what is that point? Well, that is a point, if I count the x's first, 1, 2, 3, 1, 2, 3. So that is a point of 3, 3. Remember, as a point, that gives me my x, that gives me my y. Okay, so now if I want to check this solution, so next thing, yes, this is a solution, let's check. Okay, so I can take my 2 equations. For example, y equals 2 over 3x plus 1. I can take my point of 3, 3 and plug it in for y, plug it in for x. So I'm going to take y value of 3 equals 2 over 3 times 3 plus 1. Okay, and then we simplify. 3 over those 3's cancel because 3 over 1 times 2/3 of 3 would simplify. I'm left with 3 equals 2 plus 1. So does 2 plus 1 equal 3? Yes, it does. So that one works. Okay. Now in order for this 3 to be a solution, I need to check the second equation. So I have y equals 3. Well, again, there's no x. Well, this makes it easy because what's my y value? My y value is 3. So if I plug it in, does 3 equal 3? And that should be obvious. Yes, it does. So notice how this point of 3 satisfies both equations. Therefore, this is my solution. So my solution would be a point of 3. That's the point where both lines intersect. All right, I'm going to go through this one a little quicker now. So I have my two equations. I have y equals negative x plus 3, y equals 2x minus 3. First thing I'm going to check, are these written in slope-intercept form? I should see, yes, they do match y equals mx plus b, so I am all set to go. So first thing, let's start with the first equation, plus 3. That's my y-intercept. I'm going to start with plus 3, and then I'm going to have my slope of negative 1. So that means my slope here is negative 1 over 1. So as a slope, that means I'm going to go from this point down 1, right 1. So I'm going to have a point right there. Okay, now I can draw multiple points. Notice how this graph's a little bit bigger. So I would have my line look something like that. Kind of sloppy, but that's my line. Okay, second one, y equals 2x minus 3. So I have my minus 3. That's my y-intercept. So I'm going to go down here, plot at minus 3. Then I have a slope of 2. So that means 2 over 1. Okay, so I'm going to go up 2, right 1 from this point. So again, I went up 2, right 1 for my slope, up 2, right 1. And you can see right here that when I plot that my red line is going to intersect the blue line at this point right here. Now, it was a little off because my graph is sloppy. But what is that point? Well, let's count. That's a point of 1, 2 to the right, 1 up. So that is a point of 2, 1. Okay, so I have a point of 2, 1. That is, again, my x and my y. So I'm just going to quickly check those. So I'm going to take this point and plug it into both equations. So my y value is 1, my x is 2. So I'm going to plug that in. I get y equals negative 2 plus 3. So does that work? Yes, this does give you, sorry, not negative 1. This does give you 1. Okay. Sorry about that. That is a 1. So yes, that one works. Plug it into the second one. 1 equals 2 times 2 minus 3. So 1 equals 4 minus 3. Does that work? Yes, it does. That means 2, 1 is a solution. All right, Big Dog went through those last two examples. Now it's time for you to try. So what we have, system 2x plus y equals 5, y equals x plus 2. So I want you right now, pause the video, and I want you to check your answer. I want you to go through this on your own, write it down. I'm going to pause. I want you to pause, and then the solution is going to pop up in a couple seconds here. Okay, let's take a look here. So here's what you should have. All right, so first thing you should notice, first equation, 2x plus y equals 5, not in slope-intercept form. So I took the 2x, brought it over to the right side by subtracting it. I got y equals negative 2x plus 5, and y equals x plus 2. Second equation was good. Graphed both of them again. Start with the y-intercept, plotted the slope for each, saw that they intersect at 1, 3. Took my point of 1, 3, my x is 1, my y is 3, plugged it into both equations, found that in both cases they work out, so therefore 1, 3 is a solution. So check your answers. Hopefully you got that one correct. If you did not, maybe go back and see what you did incorrectly. All right, that is going to conclude our first video lesson for this chapter. Again, if you need to rewind and go through any sections again, please do so now. Now is the time when you can pause, rewind whenever. Okay, make sure you fill out your complete packet. You'll notice that there is one example that says you try. That means right now you should be working on that last example and have that done by the time you get to class. Okay? All right, hopefully you enjoyed. Hopefully you learned something. We'll see you next time.